Welcome to video 9 in a series of introductory videos for InventorCAM. This video's topic is 3D iMachining. So using the iMachining technology we learned about in video 8, we're going to apply it in the 3D. We're actually going to do it in a target-based toolpath. So let's take a look at how that works. So I'm just going to go to Add Milling Operation, 3D iMachining. And the first thing you'll notice in the geometry section is that there is a pre-selection. It's choosing the target. So the target solid you defined back at the beginning of when you first created the file, the item that we covered in video 3 of this series, the target is the solid that we're looking at right now. So it's going to compare that to the stock. And you can see here that it's comparing it to the stock. And we can go right into choosing our tool. So in this case, I'm going to go and select our 1-inch tool. Again, because it's feeds and speeds, it's locking out because it's iMachining, it's locking out the feeds and speeds. So if we go to the data tab, you can see those are locked out. Because it is a recognition toolpath in 3D, it is actually allowing for a holder collision protection as well. So I could check this box and I can say how much space, how much clearance I want around the holder as it engages the material. And also, we're looking at this window, and this is our multi-tool selection. So what this is similar to what we saw in video 8, where I can tell it which tools I'd like to apply, and it'll output toolpaths for each tool. So in this case, we'll use the 1-inch tool, and then we'll grab the 1/4-inch tool as well. Next is levels. So for the first tool, the 1-inch tool, we're going to do up to the top of the stock, and lower level, let's do it maybe to just this face and slightly below. So we'll just put a -30 thou on that. So from this side of the part, it's just going to machine everything it finds from the target out of the stock up until that level. Under Technology Wizard, similar to what we saw in video 8, this controls the aggressiveness of the calculation. So because I have a 1-inch tool, it's giving me this color coding here indicating that I'm not using this tool in the most efficient way. The ACP actually indicates how many points on one flute are engaging the material. Because this is ending up to be a very shallow pocket, shallow bit of material, it's letting me know that there's only 0.39 of ACP. I have this robust tool. I could be using it a lot more aggressively. But I'm going to slide that up to level 8 just to bump up the feeds and speeds. We also actually have, under modified cutting conditions, additional parameters we can plug in. And you see a couple of things in here that you could add in to better fine-tune your operation. 2 things I usually point out is max spin. So I'm getting this thing to go up to just above 1500 RPM. But let's say the holder that I'm using to hold my tool can't handle that RPM. Well, I can check this box, plug in a more appropriate RPM, and then it locks that in as the maximum RPM for the toolpath. So as it goes along and regulates the feeds and speeds during the toolpath, it will make sure not to go higher than that RPM. Also, because that factors into the cutting speeds, that'll also update everything. Additionally, if you take a look at the chip thickness, you can actually regulate those if somehow you know what those should be. But a good indicator of this item here is the chip thickness. So watch these numbers as I check and uncheck turbo mode. Turbo mode doubles the aggressiveness. It actually increases the chip thickness. You can effectively think of this level now as levels 9 to 16. So that's what turbo mode does. Basically doubles the chip thickness so you can get it to be more aggressive. And you see that also in the feeds and speeds. Under technology section, similar to, again, what we saw in video 8, we have control over the wall offset and the floor offset. I can make both of those 10 thou. But because this is a 3D toolpath, we also actually have control over the scallop height as well. I'll just check this box by my mouse in there. You'll see in the bottom left corner, we can actually add steps to any kind of taper or curvature. In this case, the back face of this part has some tapers on both sides. So when I put in 10 thou in here, we'll see 10 thou steps on those faces. This is a good way to get a uniform roughing. Every face on this part will now have 10 thou material on it after we do the 3D iMachining. 3D iMachining is mostly for roughing. There really isn't any finishing features in the 3D iMachining yet. What I'll do now is I'm going to go back to the Technology Wizard, click on my second tool in my multi-tool table, and make sure that this guy is also at level 8, turbo, and that it's also leaving behind 10 thou on the walls and the floor. 3D iMachining is a recognition toolpath in every sense of the function of the toolpath, meaning that this second tool that I'm selecting is automatically a rest operation. So I'm going to do a save and calculate. It'll start with the 1-inch tool, analyze the part, see what material it can be removed using only that 1-inch tool. And then once that toolpath is done and it gets represented, it'll move on to using the 1/4-inch tool to show me what it can remove from in between those two Z levels that we selected in the level section using this tool. The Z levels you see on this progress window are basically the Z slices of the solid. So you can actually see that the toolpath itself kind of looks like a 2D iMachining on each level. You can see a little bit of scalloping on the side here, and on the top it is actually doing a what looks like a 2D iMachining. So now both of those toolpaths are done. You can see them in the operations list. If we look at the 1-inch tool, it did as much as it could inside those pockets. And if we take a look at the 1/4-inch tool, it went back and did the corners that were unable to be done by the 1-inch tool, and it did these slots. Now, let's take a look at what happens if we put a toolpath on side 1. Let me just move this guy just after there, and we'll do operations on side 1. So I'm just going to go 3D iMachining. Mac 1, position 1. Now, what I want to do with this one is let's take a look at the other side of the part. The tool has already pretty much machined everything on side 2, leaving behind a lot of material on the edges here and on the inside. So if I just do a simple 3D iMachining here, I'm just going to use basically both tools again. I'm just going to grab this tool. And the 1/4-inch tool. Levels will say to the top of the stock once again. This time though, lower level. Let's do it to just this face right here. So Technology Wizard, rev up both of those again. And Technology will leave 10 thou on the walls and the floor for both. So now, again, it's analyzing the updated stock to see what material needs to be removed. So the 1-inch tool was able to do all that material. So 3D iMachining, if you notice from the stuff that we did in video 8, it actually replaces multiple 2D iMachinings. It recognizes the stock and added a bunch of pocketing toolpaths to this one toolpath. So the 1-inch tool was able to do most of the outside and the inside, and then the 1/4-inch tool came in and did that. Now, instead of doing the entire part, let's say we just wanted to focus on the inside. Well, there is one bit of geometry that you are able to select, and that is the working area. If I just click on Define, I'll engage the working area, click on Define again, and it uses chain geometry or smart face geometry just like it did in video 8 for the 2D iMachining. In this case, I'm just going to grab the outside edge right here, let that go all the way around. And essentially what I'm telling iMachining is I want it to apply this recognition toolpath, recognizing the stock, the target, all that information, but only within that sketch. If I want the tool to stay completely inside the sketch and not even leave the sketch, then I can change it from external, which allows the tool to go outside the sketch, and change it to internal, meaning that it can only reposition and only machines what it finds on the inside of that sketch. During the course of using these parts and these toolpaths, maybe the sketching is better to be done in terms of just limiting the travel just enough that the tool doesn't leave it, but we still need to go into corners. We might want the center of the tool to go to that edge. So we can set it to center, meaning the center of the tool is able to go to that edge. It can actually leave just a little bit outside, but never actually leaving the part. Likewise, we have tangents, which essentially allows it to go just enough outside the part, but still keeping in contact, keeping a tangent point. So let's set this to internal. I'll click OK. I'll do save and calculate. It will now recalculate both tool 57 and tool 23, but only inside of the sketch. This can be useful for when you're doing a very large part and a massive recognition toolpath is not going to be beneficial, but you are looking to maybe do 3D iMachining, but just in one specific area. You're able to use the outside edges of a pocket, the edges of a solid, or if it's a really large part and you just want to specifically say what area to do, you can add a sketch. Go back to your Inventor modeling and just tell it this sketched area, model it up, and then when you come back to SolidCAM, InventorCAM, all you got to do is just say working area, select on the sketch instead, and you can limit the travel of the tool using that sketch. So just on the inside, and what I didn't do is add in a working area for the second tool. So you can see they do actually operate as separate operations. Any questions of this or anything else from InventorCAM, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this intro series. Thanks for watching.